You know, in the huge fight against cancer, one of the most exciting frontiers is actually turning our own bodies into the ultimate weapon. And today, we're going to look at some really cool research that does just that. It's about a potential dynamic duo of super engineered immune cells, programmed using mRNA tech to go after leukemia. All right, let's get into it. So, first up, let's meet our veteran hero, CAR T cell therapy. Now, this isn't some sci fi concept, it's a real, FDA approved, groundbreaking treatment. Think of it like this: you take a patient's own immune cells, their T cells, and you basically turn them into these highly specialized assassins. They get one mission and one mission only: find and destroy cancer cells. It's an incredibly powerful strategy, and we know it works. But, even the best hero can use some backup, right? And that leads to the big question behind this whole explainer and the research paper we're digging into. What if this super trained assassin didn't have to fight alone? What if it had a partner? Could that make it even better at its job? Well, that's where the promising new rookie comes in: the CAR macrophage. This is the potential partner we're going to be talking about. The idea is to take a totally different kind of immune cell, a macrophage, and give it the exact same cancer-targeting superpower. It's all about creating a brand new cancer-fighting alliance. Okay, so how in the world do you give a normal cell a superpower like that? How do you program it with these new instructions? Well, this is where the really cutting-edge stuff comes into play. It's all about delivering a very specific genetic blueprint right where it needs to go. And here's a connection that's probably gonna click for a lot of you. The technology behind this is actually really similar to the mRNA tech we all heard about with the COVID-19 vaccines. It's the same core idea: using messenger RNA, or mRNA, to give our cells a set of instructions on what protein to build. So let's break this down. It's really a four-step process. First, scientists create that mRNA blueprint. This is the code for a special receptor, called a CAR, that knows how to spot cancer. Step two, they have to protect that blueprint, right? So they package it inside this tiny, fatty bubble called a lipid nanoparticle, or LNP. Think of it as a protective envelope. Third, that LNP acts like a tiny delivery drone. It flies over to an immune cell, fuses with it, and drops off its package, the mRNA. And finally, step four, the immune cell gets the package, reads the blueprint, and starts building those cancer-targeting CAR receptors all over its surface. And just like that, you've got a newly programmed supercell ready to go. Okay, so what you're looking at here are the actual schematics from the paper. Now, I know it can look a little complicated, but the main idea is super simple. These diagrams just show how the researchers successfully engineered both types of cells. On the left, you've got the CAR T cells, and on the right, the CAR macrophages. You really don't need to get bogged down in the details here. The big takeaway is that this LNP method worked. It successfully created both of our cellular heroes for the big experiment. And one of the huge advantages of using this LNP approach is just how gentle it is on the cells. See, older methods for doing this could be really harsh. We're talking about killing off more than half the cells in the process. But with this LNP delivery system, the study found that cell viability was a stunning 97%. That's a massive difference, because obviously, more living, healthy cells means you have a much stronger army to send in to fight the cancer. All right, so we've got our two heroes. They're programmed, they're ready for action. But here's the thing: they don't fight the same way at all. It's seriously like a buddy cop movie. You've got one who's the hotshot marksman, goes in guns blazing, and then you've got the other who's the methodical detective, the one who cleans up the scene. They have totally different styles, but as we'll see, they might just complement each other perfectly. And this picture from the paper just shows those different strategies perfectly. So on the left, that's our CAR T cell, the assassin. It gets right up to a cancer cell and triggers it to self-destruct. That's a process called cytotoxicity. Then over on the right, you see our CAR macrophage, the cleanup crew. It has a totally different move. It literally just eats the cancer cell. It engulfs it and digests it. That's called phagocytosis. Two very different ways to get the job done. So let's just lay it all out, side by side. You've got the CAR T cell, the assassin. Its method is cytotoxicity. That's direct killing. It's fast and it's potent. Then you have the CAR macrophage, the cleanup crew. Its method is phagocytosis, basically engulfing the enemy. Its main role is to clear away those cancer cells. So yeah, two very distinct but super important jobs in the same fight. So naturally, the next question is, who wins in a head-to-head fight? The researchers put them to the test. They put the immune cells in with the cancer cells at a 10-to-1 ratio. And the results? Well, they were pretty clear. The CAR T cell, our assassin, just showed its raw power, wiping out an incredible 86.3% of the leukemia cells. So yeah, when it comes to pure, direct, potent killing, the CAR T cell is absolutely the champion. But really, this whole investigation was never about finding a single winner. The most exciting part of the whole story was still to come. What happens when you stop making them compete? What happens when you finally let them team up? And this right here, this is the beautiful payoff. This is what synergy looks like. You can see both the CAR T cell and the CAR macrophage working together in concert. You've got the killer and the cleanup crew, both going after the same target but from different angles. It's that classic case of the whole being greater than the sum of its parts. 1 + 1 doesn't equal 2 here. It equals something much, much more. And hey, you don't have to take my word for it. The researchers spelled it out crystal clear in their conclusion. This is really the money quote of the whole paper. They said co-culturing CAR T cells with CAR macrophages synergistically enhanced tumor cell eradication. In other words, the team-up was a massive success. All right, so what's the big picture here? What does this all mean? Let's wrap this up by hitting the key takeaways from this really amazing study and think about what this might mean for the future of fighting cancer. So here's what we learned. First, that using mRNA with these LNP delivery drones is a really effective and gentle way to program immune cells. Second, CAR T cells are without a doubt the superior direct killers. They are the assassins. Third, CAR macrophages have their own special skill, clearing out cancer cells by literally eating them. And fourth, the most important point of all, when you put the two together, they work synergistically. They're just better as a team. And this really points to a huge shift in how we think about this stuff. Maybe the future of cancer therapy isn't about finding one single magic bullet. Maybe it's about building the perfect team, a team of specialized cells where each one has a unique role to play, all working together like a well-oiled machine. This research just opens up such a thrilling new door, and it leaves us with this final, powerful question to think about. We're moving past the idea of single-player therapies. So, could designing and deploying these custom-built teams of immune cells be the next great leap in medicine? The future of fighting disease might just be a team sport after all.